As a result, we will have an inverse function. Inverse function exists. Okay. Um, okay. It seems pretty easy, but what happens is the examiners in your in math method comes with so many creative ways to ask a question on this topic, whether a function has a inverse function, okay, or how to restrict the domain so the function have an inverse function. Okay, so I do some examples now. So a common example is like that. A function, okay, a function of x is equals to x squared plus, okay, I make it a little bit harder. Okay, a function of x is equals to bracket x plus 1 bracket square plus 2, okay, and the domain of the function is square bracket a and positive infinity. Okay, and now I ask you, okay, what value, what is, okay, they will ask what is the minimum value of a so an inverse function exists. Okay, basically they ask you to restrict the domain to a minimum value of a. So what happens is, just let's draw our graph. Okay, this is a parabola graph, so I will have a turning point at -1 and 2 there. Okay, -1 and 2. I would have a, this is my graph. Okay, x and y, fx. Okay, okay, and to do that, well, we know what is the domain, the minimum domain. Well, say the domain is okay, the domain is a number, okay, until positive infinity. Okay, what will be the minimum number so that this graph is a one-to-one function, so the inverse function exists. Okay, what normally, okay, the trick of this kind of question is always go to the turning point. Okay, say we have a turning point at -1 and 2, so the minimum value of a to make this function a one-to-one function is minus a equals to -1, because -1 is a turning point. Okay, this is always the trick. Okay, so if we, okay, so the answer is a equals to -1. Okay, this is always the trick. So if we draw the graph with restricted domain, we will have a one-to-one function. Okay. Okay. Just remember, the trick is always go to the turning point. Okay, uh, a more complex example would be, well, what's happened is if, okay, if you have a graph like that, y equals to x plus 1 square times x minus 5, okay, and okay, to okay, uh, okay, and the domain is a and say 0, okay. They ask you what is the minimum number of a so that inverse function exists, okay. So let's draw the graph first. It will be something, actually it will be something like this, okay. This is a cubic function. We learned how to draw this kind of functions in okay in the chapter below, well, in the chapter before. So this is always the case, okay. So okay, basically they tell you they restrict the domain already on the right hand side to the point when x equal to 0, okay. So when I draw the graph, I can escape this part. They tell you, they ask you what is the a, so it will be the minimum number of a, it will be a one-to-one function so that an inverse function exists, okay. So the right answer is always find the x coordinate of the turning point, in this case, which is -1. So a will be -1. So if x has the function would have an inverse function, okay. If I can restrict that, okay. That's the trick. Okay, it doesn't seem very hard in those examples, but in your year 12 final year examination 2, in problem solving questions, well, almost every year, the examiner comes up with very creative ideas to ask you this kind of question, okay. It's okay, and sometimes it's almost impossible to predict the way they're going to ask you to solve this kind of question, okay. Well, my recommendation is, well, I only can recommend just read the question carefully, try to understand the question, especially in a long problem solving questions. So yeah, this is basically the idea. Okay, and I will do some more more examples with long problem solving questions, okay, in year 12 math method reduce, okay. So for now, just you have to okay, what you need is a strong fundamental knowledge about year 11 math method, okay. um, okay, okay. Thank you.